Welcome to True Projects. In this video, we are going to see impact evaluation of cyber attacks on traffic flow of connected and automated vehicles. Introduction. Connected and automated vehicles use onboard and roadside sensors to transmit speed and location information to nearby vehicles, increasing travel efficiency and preventing accidents. However, this technology faces challenges like deployment costs and cyber attacks. Attackers can target onboard sensors, sending fictitious information which can lead to accidents or traffic jams. Objective of the project. The project aims to assess the impact of cyber attacks on traffic dynamics, fuel efficiency and emissions in connected and automated vehicles. It validates false information generated by cyber attack sensors, resulting in increased accident risks, travel times, fuel consumption and emissions. The project quantifies these effects by analyzing vehicle speed, location and acceleration using simulation models. It also covers two-sided traffic scenarios, enhancing its applicability and insights. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDEL of Python 3.7 version. To execute this project, we have designed the following modules. The first module is Generate Traffic. In this module, a simulated traffic scenario is generated with a specified number of vehicles. Each vehicle's speed and location details are initialized, creating a virtual traffic environment for the simulation. The second module is Start Simulation. Upon activating this module, the simulation of the generated traffic scenario begins. Vehicles start moving based on their initialized speeds and positions. The simulation progresses and potential interactions between vehicles are observed. The third module is Calculate Attack Impact Severity. This module assesses the severity of the impact caused by cyber attacks on the simulated traffic. It computes a percentage value indicating the extent of disruption or harm resulting from the attacks on the traffic flow, considering factors such as accidents. The next module is Cyber Attack Impact on Fuel and Emission Consumption Graph. This module visualizes the impact of cyber attacks on fuel consumption and emissions in the simulated traffic. A graph is generated with the number of vehicles on the x-axis and fuel consumption or emissions on the y-axis. It demonstrates how cyber attacks leading to altered vehicle behavior affect fuel efficiency and emissions. The last module is Average Speed Graph. The Average Speed Graph module produces a graph illustrating the average speeds of vehicles in the simulation. The x-axis represents vehicle numbers while the y-axis represents the speeds. The graph provides insights into how cyber attacks influence the movement patterns of vehicles, affecting their average speeds and potentially causing disturbances in traffic flow. Execution of the project. To execute this project, first we need to open the code folder. This is the Python main code file and this is the run.bat file. Instead of executing the project in command line interface, we have created this Windows batch file. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Generate Traffic button. So here, we have set up a traffic scenario with 10 vehicles, each represented by a circle. Clicking the Start Simulation button makes vehicles move. So we are deliberately adding attackers that send false speed information to nearby vehicles. When two vehicles get too close, they turn red, indicating the attacker. During the simulation, we'll notice vehicles getting closer because of the fake speed information. Here, vehicles begin moving in both directions. When a vehicle gets too close to another, it enters an unstable region. The preceding vehicle turns red, indicating it's an attacker reporting false speed data, causing nearby vehicles to approach. The distance between vehicles is shown in the text area. Once the simulation ends, we'll see the final screen with results and analysis. Now click on Calculate Attack Impact Severity to measure how severe the attacks are. So in the text area, we can see the attack severity at 0.4%. Now click on Cyber Attack Impact on Fuel and Emission Consumption Graph. to view a graph comparing fuel and emission consumption between normal and attacked vehicles. So in this graph, on x-axis I have vehicles and on y-axis I have fuel or emission increases. So in this graph, attacked vehicles consume more fuel and emit more, unlike normal vehicles that move at a constant speed and have lower fuel consumption. For instance, in this graph, vehicles 0, 3, 4, 5, 7 and 9 show lower fuel consumption while the rest consume more fuel. Now click on Close this graph and click on Average Speed Graph button. So in this graph, on x-axis I have the vehicle number and on y-axis I have the speed. Vehicles with lower speeds are considered attackers. They provide false information and slow down, risking accidents with rear vehicles. Normal vehicles maintain an average speed. This visualization helps illustrate the impact of attackers on vehicle speeds and potential traffic disruptions. Close this graph, and the conclusion here is this project highlights the impact of cyber attacks on connected and automated vehicles, traffic flow, fuel consumption, and emissions. It demonstrates that attackers can manipulate sensor data, leading to accidents, increased fuel usage, and emissions. The impact assessment emphasizes the vulnerability of advanced vehicle systems to malicious interventions and the need for robust cybersecurity measures for safe and efficient transportation in the era of connected and automated vehicles.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.